Alright guys, in this video, we're getting to chapter 8. We're talking about hypothesis testing for this chapter, and we'll start with section 1, hypotheses and test procedures. First of all, let's take a look at the definition here. Let me pull out the marker. So it says a hypothesis is a statement regarding a characteristic of one or more populations. In this chapter, we'll look at hypotheses regarding a single population parameter. So basically, when we're talking about the statement regarding characteristic, we're talking about the parameter here. So as what we did in chapter 7, in chapter 7, we learned how to estimate the population mean and population proportion. And in chapter 8, we're going to learn how to do the hypothesis testing for the population mean and population proportion. So the characteristic over here means the parameter. All right, let's take a look at the examples of claims regarding a characteristic of a single population. So it says in 2008, 62% of American adults regularly volunteer their time for charity work. A researcher believes that this percentage is different today. All right, so you don't have to worry about anything else. So we just need to try to determine which parameter we're working here. So the only number we have is that 62%, right? So we're working with the parameter we're working with here is the population proportion P, which is 0.62. So we're working with the population proportion over here. All right, let's take a look at the second example. According to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. So which parameter we're talking about? Since it says mean length, so we're talking about the population mean mu, so which is 3.25 here. That's the parameter we're talking about here. Let's take a look at number 3. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. Of course, this is standard deviation. With new equipment, the quality control manager believes that the standard deviation has decreased. So which parameter we're talking about? We're talking about the population standard deviation, which is equal to 0.23, based on the number given here. All right. There's a caution here. If the population data are available, there's no need for inferential statistics. Actually, same thing for chapter 7 as well. The reason why we estimate the population, the reason why we estimate the parameter, or why we do the hypothesis testing for the parameter, is because that we are not able to access to the whole population. Okay, if we're able to access to the whole population, we can just go ahead to the calculation directly, right? Based on the formulas we learned in chapter 1. So the reason why we are doing the hypothesis testing or estimating the parameter here is because we're not able to access to the population data. All right, once this is clear, let's take a look at hypothesis testing. Hypothesis testing is a procedure based on a sample evidence and probability used to test the statements regarding the characteristic of one or more populations. So of course, we're only working with one population in this chapter, and it says that based on a sample evidence and probability used to test statements regarding the characteristic. Of course, the characteristic here represents the parameters. It could be population mean mu, or the population proportion P, or the population standard deviation sigma. Okay. All right. Once we know that, let's take a look at this non-hypothesis. Non-hypothesis, denoted by H sub 0, is a statement to be tested. The non-hypothesis is a statement of no change, no effect, or no difference, and is assumed true until evidence indicates otherwise. So just keep the idea in your mind. The non-hypothesis denoted by H sub 0. Okay, and it's a statement of no change. That means it's a statement containing an equality. We'll see a little bit more details about that later. So once we know the non-hypothesis, the opposite of it is called alternative hypothesis, denoted by H sub 1. is a statement that we are trying to find evidence to support. So basically, based on the definition we just went over, the hypothesis testing we are doing here is the alternative hypothesis versus the non-hypothesis versus the alternative hypothesis. Okay, and then let's take a look at how to set up the non-hypothesis and alternative hypothesis. All right, in this chapter, there are 3 ways to set up the non and the alternative hypothesis. So we have 3 different kinds of hypothesis testing. So one is called equal versus not equal hypothesis. So this kind of test is called two-tailed test. And for the non-hypothesis, we're going to have a parameter is equal to some value. And for the alternative hypothesis, we're going to have the parameter is not equal to some value. So as what I just mentioned, when we're talking about the definition of a non-hypothesis, we know that the non-hypothesis is a statement containing a equality, like always, okay, like always. So that's why we have this equipment over here. And the reason why this is called a two-tailed test is because this not equal sign here. Okay, so since we have the parameter is not equal to some value in the alternate hypothesis, so it could be the parameter is greater than some value or the parameter is less than some value. Okay, it could be the parameter greater than some value or the parameter is less than some value. That's why it's called two-tailed test. Okay. Number 2 is called left-tailed test. Once again, the alternate hypothesis is always a statement containing an equality. It's always a parameter equals some value. Since it's a left-tailed test, in the alternate hypothesis, we're going to have the parameter is less than some value. That's why it's called left-tailed test, because the parameter is on the left-hand side of some value given here. So of course, the third one would be called the right-tailed test. And once again, the statement of the non-hypothesis is always the statement containing the equality, which is the parameter is equal to some value. Since it's a right-tailed test, we're going to have parameter is greater than some value in the alternative hypothesis. So that's pretty much the 3 different kinds of tests that we're going to meet in this chapter or in this whole class. All right, let's take a look at this in other words. The non-hypothesis is a statement of status quo or no difference and always contains a statement of equality. The non-hypothesis is assumed to be true until we have evidence to contrary. We seek evidence that supports the statement in the alternative hypothesis. So basically the statement of non-hypothesis is all the statement containing the equality, like always. But what is alternative looks like? It depends on the problem. It could be two-tailed test. If it's a two-tailed test, then we're gonna have the parameter is not equal to some value in the alternate hypothesis. If it's a left-tailed test, we're going to have the parameter is less than some value in the alternate hypothesis. If it's a right-tailed test, we're going to have a parameter is greater than some value in the alternate hypothesis. So we're going to see the examples of all 3 tests. Now let's take a look at the example here. For each of the following claims, determine the non and alternate hypothesis. State whether the test is two-tailed, left-tailed, and right-tailed test. Let's take a look at part A. In 2008, 62% of American adults regularly volunteer their time for charity work. A researcher believes that this percentage is different today. Okay, now let's take a look at how to set up the non and alternate hypothesis for this one. So first of all, let's take a look at which parameter we're working with here. We're working with since the percentage, right? So it's a population proportion, and we know that the non-hypothesis is always the statement containing the equality. So in this case, we're going to have P is equal to 0.62 for the non-hypothesis, and then versus. Now let's take a look at the alternative hypothesis. So the problem says a researcher believes that this percentage is different today. So we're talking about this difference. That means it could be greater than 0.62, or it could be less than 0.62. So anyway, is P is not equal to 0.62. So what kind of test is this? Since we have P is not equal to 0.62 in the alternative hypothesis, so this is a two-tailed test. Okay, this two-tailed test. All right, I wish this makes sense to you. Let's take a look at part B. According to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of call has increased since then. Now let's take a look at what is the non-hypothesis over here. So first of all, which parameter we're working with? We're working with the mean length, so which is the population mean. So mu would be equal to, so it was equal to 3.25. So once again, so non-hypothesis is always a statement containing the equality. And the versus, what is the alternate hypothesis? So the problem says the researcher believes that the mean length of a call has increased since then. So if it believes that it's increased, so that would be mu is greater than 3.25. So this is a right-tailed test. This is the right-tailed test. Okay, because it's greater than. So, and this is why that I said that for the hypothesis testing, we're trying to find evidence to support the alternate hypothesis. We can get that point from the problems directly, because it says the researchers believes that the mean length of a call has increased since then, and the mean was 3.25. So the mean was 3.25, and the researcher believes that it has increased. So we're seeking the evidence to support the alternative hypothesis over here. Okay. All right, let's take a look at the part C. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. So first of all, which parameter we're working with here? We're working with the population standard deviation, right? So what was it? It was 0.23, and versus the alternate hypothesis. What's the alternate hypothesis? The manager believes the standard deviation has decreased. So the alternate hypothesis would be the sigma is less than 0.23. And of course, this is a left-tailed test. Okay, I think this is quite straightforward, and I wish it makes sense to you as well. So the solution given here, so let's just read it over for quick, is pretty much exactly the same thing as what we got above. Above here. So for part A, the alternate hypothesis, the non-hypothesis is h sub 0, p is equal to 0.62. So whatever on the homework problems on the test, you don't have to write down the whole thing that the non-hypothesis is. You don't need this part, okay? You just need what you need is h sub 0, and then p is equal to 0.62. And then alternate hypothesis would be h sub 1, p is not equal to 0.62, and of course this is a two-tailed test as what we mentioned before. Alright, part B, the non-hypothesis mu is equal to 3.25, alternative hypothesis is mu is greater than 3.25, and it's a right-tailed test. Same thing as what we got. Part C, the non-hypothesis sigma is equal to 0.23, and the alternate hypothesis sigma is less than 0.23, and it's a left-tailed test. Okay, exactly same thing as what we got up above. So once we know how to set up the non-alternate hypothesis, let's take a look at what kind of possible outcomes we could get from the hypothesis testing. So number one, we could reject the non-hypothesis when the alternate hypothesis is true, and this decision could be correct. this makes sense intuitively because as what I just said, that we are looking for, if we write down this is alternative non-hypothesis versus alternative hypothesis H sub 1, and we are trying to find evidence to support alternative hypothesis. If we do find evidence to support this alternative hypothesis, of course we're gonna reject the non-hypothesis, and of course from this we're gonna have a correct result. So this is the first possible outcome we can get: reject the non-hypothesis when the alternative hypothesis is true. Okay, number 2, do not reject non-hypothesis when the non-hypothesis is true. And this decision would be correct as well. So let me just write it down. So this is non-hypothesis versus the alternative hypothesis. And once again, we're trying to, for the hypothesis testing, we're trying to find evidence to support alternative hypothesis, right? But if we don't find evidence to support the alternative hypothesis, of course, we don't reject the non-hypothesis because we don't find the evidence to support the alternative hypothesis over here. And from this outcome, we're gonna get a correct result as well, because if we are not able to find the evidence to support alternate hypothesis, of course we do not reject the non-hypothesis. Okay. All right. Number 3, reject non-hypothesis when the non-hypothesis is true. So if the non-hypothesis is true, we do not reject non-hypothesis. But if we reject non-hypothesis true when the non-hypothesis, if we reject non-hypothesis when the non-hypothesis is true, this decision would be incorrect. And we're making mistake. We're making an error here, and this type of error is called type 1 error. Okay, so type 1 error is reject the non-hypothesis when non-hypothesis is true. Okay, that's the type 1 error. All right, let's take the fourth one. Do not reject non-hypothesis when the alternate hypothesis is true. So technically, if we find the evidence to support the alternate hypothesis, we should reject the non-hypothesis. But if we do the opposite, if we do not reject non-hypothesis when the alternate hypothesis is true, we're gonna make a mistake because the decision would be incorrect. And this kind of error is called type 2 error. So the type 2 error is equal to do not reject the non-hypothesis when alternate hypothesis is true. Okay, that's the 4 possible outcomes we could get. All right, now let's take a look at so for each of the let's take a look at the examples here. For each of the following claims, explain why it would mean to make a type 1 error, what would it mean to make type 2 error. So let's just go ahead to jump to the let's just take a look at the examples here. Actually, that's exactly the same one as what we saw before. So the first one is in 2008. In 2008, 62% of Americans adults regularly volunteer their time for charity work. A researcher believes that this percentage is different today. So if we want to set up the hypothesis test, the non-hypothesis would be P is equal to 0.62 versus the alternate hypothesis H1, which is P is not equal to 0.62. Okay. It is because that it says the researcher believes that this percentage is different today. All right, so what does it mean by make a type 1 error? So the type 1 error means that reject non-hypothesis when the non-hypothesis is true. That means in this case that we reject. Let's just take a look at solution directly. So a type 1 error is made if the researcher concludes that P is not equal to 0.62 when the true proportion of Americans 18 years or older who participated in some form of charity work is currently 62%. So that means that if the researcher concludes P is not equal to 0.62, that means reject H sub 0, right? They're rejecting the non-hypothesis over here when H sub 0 is true. That's what it's doing here, okay? Because this part represents the non-hypothesis is true, but this part over here represents rejecting the non-hypothesis. That's why we're saying is making a type 1 error. Now let's take a look at the what does the type 2 error looks like. So type 2 error is made if the sample evidence leads the researcher to believe that the current percentage of Americans 18 years or older who participated in some form of charity work is still 62%, when in fact this percentage differs from 60%. So type 2 error is do not reject non-hypothesis when the alternate hypothesis is true. So what it's doing here, it says when in fact this percentage differs from 60%, which means the alternate hypothesis is true, right? But the conclusion is that the sample evidence leads the researcher to believe that the current percentage of Americans 18 years or older who participated in some form of charity work is still 60%. Okay, so if they believe the percentage is still 60%, that means that they do not reject the non-hypothesis test. They do not reject the non-hypothesis when the alternate hypothesis is true, and that's why we say they're making a type 2 error here. All right, let's take a part B real quick. So according to a study published in March 2006, the mean length of phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of call has increased since then. So if we want to set up hypothesis test, the non-hypothesis would be mu is equal to 3.25, and the versus mu is greater than 3.25, and of course this is a right tail test. Okay, and then let's take a look at what does the type 1 error represents here. Type 1 error occurs if the sample evidence leads to the research to conclude that mu is greater than 3.25 when in fact the actual mean call length on cellular phone is still 3.25. So type 1 error is reject non-hypothesis when the non-hypothesis is true, right? So it says the sample evidence leads the researcher to conclude that mu is greater than 3.25. That means they are rejecting the non-hypothesis, but in fact the actual mean call length on a cellular phone is still 3.25 minutes. So that means H sub 0 is true. That's why they're making type 1 error, because they're rejecting the non-hypothesis when the non-hypothesis is true. All right, let's take a look at this type 2 error. A type 2 error occurs if the researcher fails to reject the non-hypothesis that the mean length of phone call on a cellular phone is 3.25 minutes when in fact it is longer than 3.25 minutes. So it says that we know the type 2 error is do not reject the non-hypothesis test, the non-hypothesis when the alternative is true. That's what I'm doing here. Let's take a look at why. Because it's when in fact it is longer than 3.25 minutes. That means the alternate hypothesis is correct, right? But what they're doing here, they fail to reject the non-hypothesis. That means they conclude that the mean is equal to 3.25 25. That means they do not reject null hypothesis when the alternate hypothesis is true. That's why we say they're making type 2 error here. All right, I wish this makes sense to you. And we have two kind of special notations here. So we use alpha to represent the probability of type 1 error. Of course, the type 1 error is rejecting null hypothesis when null hypothesis is true. And we use beta to represent the probability of type 2 error. And of course, the type 2 error is equivalent to not rejecting the null hypothesis when the alternate hypothesis is true. Okay, this two important notation here, especially the alpha. Okay, alpha is equal to the probability of making a type 1 error. All right. Once this is clear, let's take a look at this part here. So the probability of making type 1 error, alpha, is chosen by the researcher before the sample data is collected. The level of significance alpha is the probability of making a type 1 error. So alpha is also called the level of significance, and the level of significance is the probability of making a type 1 error. Okay, this is a very important idea for this chapter here. All right, let's take a look at this caution here. So when we are making conclusions, we never accept the null hypothesis, because without having access to the entire population, we don't know the exact value of the parameter stated in the null. Rather, we say that we do not reject the null hypothesis. We say we do not reject null hypothesis. This is just like that the court system. We never declare defendant innocent, but rather say that defendant is not guilty. So basically, when we are making the conclusions for hypothesis testing, there are just two kind of different situations. Number one, reject the null hypothesis if we find the evidence to support the alternative. Situation 2, we do not reject null hypothesis because we do not find the evidence to support the alternative. Okay, that's the only two situations we're going to have in the conclusions. Reject null hypothesis or do not reject null hypothesis. Okay. All right, just like let's take a look at the example of stating the conclusion here. So let's just go to the solution part. Let's take a look at the part A here. Suppose the sample evidence indicates that the null hypothesis would be rejected. State the wording of the conclusion. So the we're only talking about one example over here. The example is according to a study published in March 2006. The mean length of a phone call on the cellular telephone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. So if we want to set up the hypothesis testing, we're going to have H sub 0 is mu. Mu is equal to 3.25 versus the alternative mu is greater than 3.25. And the part A is saying, suppose the sample evidence indicates that the null hypothesis should be rejected, state the wording of the conclusion. So if we reject null hypothesis, I would say we reject null hypothesis if there is sufficient evidence to see that the alternate hypothesis is true, okay? Or we find the sufficient evidence to support the alternate hypothesis. So that means, in this case, the conclusion looks like reject the null hypothesis. There is sufficient evidence to conclude that the mean length of phone call on a cell phone is greater than 3.25, which means there is sufficient evidence to support the alternate hypothesis. Okay, that's your conclusion should look like if you reject null hypothesis. Okay, that's your conclusion should look like if you reject the null hypothesis. Now let's take the part B. Suppose the sample evidence indicates the null hypothesis should not be rejected. State the wording of the conclusion. So if we do not reject the null hypothesis, so we could say fail to reject or just fail to reject. Okay, just fail to reject because there is inefficient evidence to conclude that the mean length of a phone call on a cell phone is greater than 3.25 minutes. So that means there is insufficient evidence to support alternate hypothesis. And this should your conclusion look like if you fail to reject non-hypothesis. Okay? And once again, there are only two possible situations in your conclusion. Reject non-hypothesis. Your conclusion is supposed to look like this whole thing here. And the situation number 2, fail to reject non-hypothesis, and your conclusion should look like something like that. All right, that's pretty much all about 8.1. I wish it makes sense to you. All right, that's all.